We are just between you and drinks. Good place to put us, Pavel. So we're gonna just jump straight into it, and I will kick it off. Um, no more introductions needed. I'm just go straight. Burcin and I asked you to start the conversation. They want us to talk about innovations at the intersection of the brain economy and nature economy. Describe that intersection. What's there? What makes the intersection interesting?
Absolutely. First of all, thank you, Pavel and Harris, for having us. And thank you. You guys, it's been a long day, but really, really invigorating day. And I want to take a moment and want to make you look outside the window. And we are right by Central Park, beautiful trees. And as it relates to nature, we know that nature and spending time in whether it's urban nature, parks, or outside in forest, it's extremely good for our brains. We know it's really good for our mental health. It helps us focus, pay attention. It helps us with executive functioning. So even spending some time outside in the park and then coming back for people to do really difficult exams or executive functions, people have been doing much better and had students had a greater ability to focus after spending time in the green. In fact, they had done some studies where they had looked at the recovery of patients from minor operations in the hospitals when they had in two separate rooms. One had an abstract painting hung on the walls, and one had a picture of just nature. It wasn't even like what we can see live here, but it was just a picture of nature. And they had found that the patients that had spent time in the room with the picture of nature had recovered faster. These were the same operations with the same, more or less the same health conditions. They were able to recover faster. They were able to need less medication, pain medication, and so on. So nature has a really restorative power on our brains, on our health, and of course on the environment. And when we think about heat waves, having some urban nature can really decrease the temperatures and make it more habitable. It cleans the air. But and we humans it's have a huge impact on nature too, and we have not been treating it well. We know that our planet is going through major ecological crises, anywhere from climate change to biodiversity loss to pollution. And we are finding, I'm a neuroscientist who have been studying brain health for over 20 years. And what we're learning more and more with the emerging evidence is that we cannot talk about brain health by just looking at the neurons themselves. Our brains are connected. First of all, neurons themselves within the brain live in an ecosystem with these other types of cells, and our brains are connected to our gut and our bodies, and our bodies are connected to the environment. Anywhere from heat to air pollution to extreme weather events that are related to climate change and the and similar ecological crises are impacting our cognition, our memory. We had heard from George today talking about Alzheimer's, and we know how now air pollution is considered one of the greatest modifiable risk factors for Alzheimer's and other forms of dementia, Parkinson's disease, stroke. But we are also learning. We have an incredible scientist here with us today, Frederica Pereira. I don't know where she is right now, but she's a leading expert in had done studies on pregnant women for years, 30 years cohorts, where she had looked at pregnant women who have been exposed to air pollution, and she had found that the babies that were born from these mothers had structural changes in their brains. They had neurodevelopmental delays. They were slower to walk, slower to talk. They had they had higher risk of being diagnosed with neurodevelopmental disorders such as autism and ADHD. And later in life, in adolescence and young adulthood, they had higher incidences of depression, anxiety, and other mental disorders. We know that these environmental effects can really have, and as well as social environments and everything, has lifelong impacts on our brains, which makes it really critical for us to think about the power of nature has on us, on our health, on our brains, but also the power we have on the nature. And it's really important to talk to different stakeholders, different, as we want to translate science into action, we have to talk to different stakeholders, different places. And that's why I'm very excited to partner with Lawrence, because he is an expert in speaking to all these different stakeholders and finding a common language in that. So please, Lawrence, can you tell us more about that?
So look, the thing here is, right, we've heard a lot today about George talked about the need for action, right? And I'm not a neuroscientist. I am a amateur neuroscientist, thanks to Harris. But I spend my time looking at electrons, and there's a similarity between electrons and neurons. I love electrons; they're much more interesting than neurons, I thought. Now I know they're not. But on a more serious note, for me, innovation at the nexus or the intersection spins to three things. The question is, how do we scale up investments, which is the theme of this panel or this conference? Three short things from an innovation. It's not about technology. There's enough technology innovation. The first innovation is communications. How do we talk about the brain economy in a way to get not us in this room interested, because we are acolytes. It's the average person out in the street. So my first point is, can we come up with a different way to talk about the brain economy so that the next time we meet in this room, 50% of the people here will not be here? Because I would rather have 50% of people who are new converts to this movement. So the first thing is, how do we attract more people to the movement? That's the first innovation. The other innovation around attracting capital. And for that, I think we need to look at what I call co-opetition. I am so exhausted with industries having siloed mentality when it comes to going after money to transform the industry. So instead of all of these small little movements here, I'm going after this grant or this grant, why don't we start thinking as an ecosystem? Because when I talk to investors, and I talk to a few of them, the big ones do not want to fund $1 million project. It's a waste of their time. What they want is a $200 million project. Well, most companies or most organizations, perhaps in this room, cannot put together a proposal for a $200 million project. But collectively, we can. So we need innovation around co-opetition. How can we work together to make this work? My last innovation. How many people here want to have a six-pack abs? Good. So here's the problem. I tried myself and I discovered you cannot have a six-pack app if you don't have a six-pack brain. And what is stopping you from getting your six-pack app is that you do not have a six-pack brain. Because guess what? Your brain drives the effort you need to get your six-pack app. So go home today. The key takeaway from this panel is that you will strive to get a six-pack app by first getting a six-pack brain. Because you can have all the muscles in the world. If the brain is not fit, we know a lot of boxers, we know a lot of NFL players who are very muscular, well-built, but they do not have healthy brains. So my the other innovation here is, how do we reimagine what we mean by having a fit body without first getting a fit brain? My question for you then, because you're the neuroscientist, help us understand, how do we reimagine the conversation, all the research that was discussed? How do we translate all of that very good science research into actionable things that people can do today?
Yeah, that's a great question. That's something we don't really have answers, but we've been working on, and it's about how I think it's a responsibility of us scientists who are creating these data to get out of our labs, which I had done decided to do as well, because there was the frustration of not seeing any changes in the information we find. We have to get out and talk to different people, so communication being really part of it, and really think about how can we turn it into action, into policies. How can we work with communities? Learn from them. So in our case, for someone studying climate change adaptation and how to make our brains more resilient and communities more resilient, we have to get out there, talk with the communities most impacted, and I'm talking about children, the aging populations, the communities of color, marginalized communities, the global south, because climate change impacts all of us, but not equally. And there's a whole element of justice and equity we've been talking about in our pre-conversations, that we have to think beyond when we're talking about brain health and planetary health or energy industry or anything. We have, if we don't involve everybody in, we're missing out.
I think my last point on innovation, because I know Pavel wants us to get off the stage here very quickly, is the point George made about talking to politicians. So earlier today, I asked a question about the workforce. Nothing pains me more than when I go into my parking garage at work and I see a guy sitting in that parking garage who is going to be sitting there for 8 hours, sucking in all that fume in the dark. And I say to myself, okay, you know what? When I go back to DC, I'm going to go to those guys and give them masks because no one is thinking about their health. Those guys, frontline workers, field workers, utility crews, they're the ones we need to be thinking about because if this movement is supposed to scale up, it's not going to be the knowledge workers who makes it scale. The more we can get labor unions and others involved in this movement, the bigger the chance. So my last question to you then, Burcin, is from a scientific standpoint, how do you simplify brain economy in a way that George and others can go and get the labor unions and others to jump behind this movement? Because we in this room can't do it. So what recommendations would you give in terms of innovative way to communicate science to sort of the marginal groups or small groups that don't have access to all this knowledge which we do in this room?
We didn't practice this question, Lawrence.
No, because, well, I know we didn't practice this question, but you see, when you have a fit brain, you got to be agile. You have to be flexible, right?
Yeah.
Sorry, I know we didn't practice it,
It's all
but
good. No, that's a great question. I think health is the thing that unites us all. When we talk about the health of, if we can tell about the impacts of heat on our children's cognition, or if you have a mother with dementia and talking about how the environment they're in may be impacting and worsening their conditions and may be a risk factor for you. I think we all are humans. We are all connected to other humans. So bringing that element of health and how everything's connected will be, I think, the key way to bring everyone together in this movement.
well, Pavel, my last comment. So George challenged us at the last time we met in Houston that we should all try and go leave the conference and do something actionable. So I left and I went and I wrote a paper with help from Harris. And that paper, surprisingly, was accepted and published by one of the world's largest law firm, Denton. And the title of the paper was Unlocking Brain Capital, the Catalyst for Systems Change. So George, things are happening. So we're getting some movement because for Denton to jump on board tells us that people are beginning to listen. So I'm guessing you would challenge everybody else to go back and do something. I've done mine for the rest of the year, so I can lay back now. So good. All right. Thanks.
I have the unenviable task of teaching the brain science of resilience and mental health in under 3 minutes. So here we go. It's through the resilient mindset model. The resilient mindset model has 3 parts. And we should be getting some visuals up there soon, but I'm not going to eat into it. All right. Has 3 parts. The first part is the 4 S's of resilience that you see in the dragonfly's wings. Our response to any challenge, good, bad, big, or small, is based on the way we think about those 4 S's: self, situations, supports, and strategies. The cool thing is that we can use those 4 S's as a framework to prepare for, handle, and reflect on any challenge, good, bad, big, or small. And when we do, we can proactively build more resilient brain pathways. Second part of the model is the 4 characters of the brain that explain the way that our brain evolved to respond to challenges. We think of challenges as good versus bad. Our brains don't think in good, bad. They think in long-term versus short-term. So the ant is in charge of our long-term decisions, things we don't feel like doing right now, but we do them because they'll benefit us later. The ant also holds the tools of a healthy brain. When we have those tools in place, we're better able to make those long-term decisions and foster our mental health. The grasshopper represents the function of the brain for the short-term decisions. Grasshopper doesn't care if we go to the doctor or put money in the bank or study for the test, kind of wants to eat Cheetos and watch Netflix. The grasshopper is also in charge of fight, flight, and freeze, getting us out of the way of danger. It is also where we get a lot of neurochemicals like dopamine, serotonin, oxytocin. So when we work really hard towards a goal and we struggle and we finally succeed, we get a big burst of those neurochemicals. So we say that last visual represents the fact that self-esteem is not a gift you can give someone. It's a neurochemical response you rob them of if you don't let them struggle. The third character is the glowworm. The glowworm represents the amygdala, which is in charge of looking out for threats to the brain. When the amygdala or glowworm sees a threat, it goes red alert. Its job is to switch control of the brain from the ant to the grasshopper, put us into fight, flight, or freeze, get us out of the way of the oncoming car. What a lot of people don't realize is the brain evolved during tribal times when it was just as dangerous to get left out of the tribe as it was to get eaten by a saber-toothed tiger. So the brain evolved to respond the same way to social threats and rewards as physical threats and rewards. So if we have a threat to respect, equity, alliances, control, territory, or similarity, we also go red alert, switch control of the brain to the grasshopper, put us in fight, flight, or freeze, and we say and do things that are not in our best long-term interest. The dragonfly's job is to know when to override that response and say, no, we've got this. We don't need to go into fight, flight, or freeze because we have these 4 S's in place. We have resilience. We have an action that we can take. That is the entire resilient mindset model. I am really excited to announce we have curriculum that teaches this and teaches brain-based mental health literacy from kindergarten through college. And we just this week launched a YouTube channel to teach it to preschoolers. So it is called Danny Dragonfly. And so we actually have QR codes. We'll be there. Whoops. We will be in the back in the cocktails to answer questions if you have them, but that is your brain in 3 minutes or less.